What exactly is the M982 Excalibur? What are its features and where is it deployed? Hey y'all, welcome back to the channel. In today's video we'll be going through the most deadly artillery in the US military, the Excalibur M982. Before we get into the video, kindly note that the information provided in this video is for educational purposes only. Without further ado, let's dive in. The M982 Excalibur, formerly XM982, is a 155mm extended range guided artillery shell developed by the US Army Research Laboratory and the US Army Armament Research, Development and Engineering Center in collaboration. It is a GPS and inertial guided munition that can be employed in close support circumstances within 75 and 150 meters of friendly soldiers or in situations when targets are too near to civilians for traditional unguided artillery fire to be effective. The US planned to purchase 7,474 rounds in 2015, with a total program cost of $1.9 billion and an average unit cost of $258,777. By 2016, the cost of a round had dropped to $68,000. In 2015, tests with laser guidance capability and meant to be launched from naval guns began. Over 1,400 rounds have been fired in combat as of October 2018. Excalibur was created as a long-range alternative to traditional artillery projectiles with increased precision thanks to GPS guidance. Excalibur has a range of 40 to 57 kilometers, depending on the configuration, and a circular error probability of 4 meters. Folding guide fins, which allow the projectile to glide from top of the ballistic arc towards the target, are used to achieve the increased range. Raytheon Missiles and Defense of the United States and Base System Bofors of Sweden collaborated on the weapon. When firing in a straight line from the launching cannon is limited by terrain, Excalibur is used to minimize collateral damage for targets beyond the range of standard munitions. For precise firing within 150 meters of friendly troops and for targets beyond the range of standard munitions, it has a multifunction fuse that may be configured to detonate in the air when it collides with a hard surface or when it penetrates into a target. A single Excalibur bullet can hit an intended target with a precision of 10 to 50 unguided artillery rounds. Excalibur's first combat experience in Iraq in the summer of 2007 was a huge success, with 92% of bullets hitting their target within 4 meters. The US Army planned to raise output to 150 rounds per month from the existing 18 rounds per month due to its outstanding performance. Excalibur rounds broke new combat range records of 36 kilometers in 2012. The round was successfully tested to a range of 43.5 miles in December of 2020. Utilizing a supercharged propellant fired from a 58 caliber ERCA gun tube. The British AS-90 SPG, Swedish Archer artillery system, South African G6 howitzer, US M198, M777 lightweight, and M109A6 Paladin self-propelled 155mm howitzers, and the German Panzerhaubitze 2000 are all Excalibur projectile-compatible guns. Following the abandonment of long-range land attack projectile, the US Navy explored putting the Excalibur in the advanced gun system of the ZUMWALT-CLASS destroyers, but the concept was scrapped. Excalibur began in 1992 as a development initiative. The May 1997 operational requirement document called for 200,000 rounds of an unguided munition with a greater range at the cost of $4,000 per round, and on January 23, 1998, Texas Instruments was granted the first EMD contract. The volume was lowered to 76,677 rounds in November 2001, and then to 61,483 rounds shortly after. Although the developers were encouraged by India's use of the Russian Krasnopol guided shells against Pakistani bunkers during the Kargil War in 1999. The program was integrated with a Swedish-US program to develop trajectory-correctable munitions in March of 2004, as evidenced by a new ORD issued in September 2004 that replaced the dual-purpose improved conventional munition cluster bomb variation with the discriminating munition variant. The US Army cut its planned order to 30,000 rounds later that year. In May of 2005, low-rate manufacturing of 500 rounds was permitted, and the Raytheon was awarded a $22.1 million contract to produce 165 rounds in June of 2005. The round was successfully demonstrated at the Yuma Proving Ground in Arizona in September of that year. In June of that fiscal year, Raytheon was granted a $42.7 million contract for the manufacturing of 335 Excalibur projectiles, as well as supporting test pieces and services. Technical issues with environmental sensitivity and GPS signal log were detected in August of 2006, delaying the projected in-service date to spring of 2007. In September, testing revealed an average CEP of 5 meters or better. Early in 2007, Increment IA-1 finished testing, and the US Army approved an urgent material release in April of that year, allowing deployment to Iraq. In May of 2007, the Excalibur was fired for the first time in Iraq. In April 2007, Increment IA-2 demonstrated a range of 40 kilometers in a live-fire demonstration, and the Army Acquisition Executive authorized the Milestone C decision for IA-2 to commence low-rate manufacturing in July. Sweden contributed $55.1 million to the development of the munition, and service rounds are slated to arrive in 2010. In February 2008, the Excalibur made its debut in Afghanistan. In October 2007, the Australian Army placed a $40 million purchase for the Excalibur rounds, which was later increased to an estimated $58 million in April 2008. The cost of a unit in 2008 was $85,000. Raytheon and Alliant Tech Systems were both given competitive development contracts for incremental IB mass production in September 2008, but Raytheon was awarded the final manufacturing contract in August of 2010. In March 2009, test firing Increment IA-1 rounds revealed that the Honeywell Inertial Measurement Unit was deficient, and it was replaced with an Atlantic Inertial System Unit. In April 2010, the US Army plan order was reduced even more, from 30,000 to 6,264 rounds, resulting in a significant rise in unit costs, prompting an investigation under the Nunn-McCurdy Amendment. Normally, a breach of the Nunn-McCurdy Act indicates that a program is in peril, but a 2012 RAND assessment showed that the increase in unit costs were caused by reductions in procurement numbers. Due to the increased precision of modern artillery, fewer shells were required to have the same effect. The Excalibur provides brigade commanders in the United States with a precise weapon that can be used locally regardless of weather conditions, unlike bombs dropped from an aircraft. Because the M982 is so accurate, the possibility of friendly fire deaths and collateral damage is no longer a deterrent to utilizing gun artillery in urban areas, and the Excalibur is sometimes called in only 50 meters away from friendly infantrymen. In February 2012, a US Marine Corps M777 Howitzer in the Helmand Province, Afghanistan, fired a single Excalibur round at a Marine record range of 36 kilometers, killing a group of insurgents. Raytheon was awarded a $56.6 million contract for low-rate initial production of Excalibur IB projectiles in December 2012. Raytheon was also awarded a $54 million contract for the second batch of Excalibur IB artillery rounds on September 10, 2013. The Excalibur IB outperforms the earlier Excalibur IA-1 and IA-2 in terms of dependability and unit cost. Over 690 Excalibur projectiles have been fired in the theater at the time of the award. The US Army and Raytheon fired 30 Excalibur IB shells at test targets in February 2014 to ensure the configuration's performance and durability before going into full-rate production. Projectiles fired from the Paladin and the M777 howitzers at ranges ranging from 7 to 38 kilometers, with each hitting the target within 1.6 meters. The final Excalibur IA projectile was assembled on April 3rd of 2014, indicating the shift to increment IB concentration. The US Army and Marine Corps, as well as a number of international customers, received around 6,500 IA shells. The Excalibur IB's initial operational test and evaluation was completed in May of 2014, bringing the projectile closer to full-rate manufacturing. The Excalibur IB had an average miss distance of fewer than 2 meters during testing. Raytheon was awarded a $52 million contract on July 31st of 2014 to begin full-rate manufacture of the Excalibur IB shell. Raytheon successfully tested the Excalibur S shell with dual-mode GPS SAL guidance system in June of 2014. A laser spot tracker is built into the Excalibur IB shell in this variant. The test used GPS coordinates to evaluate the LST's ability to survive being launched from a howitzer, and a laser designator directed the shell to the target. Raytheon stated in February 2020 that the Excalibur S's laser seeker has been successfully tested against a moving target. So, what should we cover next? Do let us know in the comment section below. Also, don't forget to smash that like button and press on the bell icon to get notified about our new videos. If you enjoyed this video, please check out our other videos. But until then, stay tuned.